Welcome to qnawire.
When a nucleus undergoes decay, it produces a more stable nucleus. There are different types of decay. In this problem, we're looking at the idea of beta decay, which means that this particle is produced. Another form of decay that we may see is positron, or B positive, which means that this particle is produced. Both decays are initiated by a neutron bombardment. So one of the reactants is always a neutron, which has this symbol here. And we can predict the products of each reactant by remembering that the mass numbers and atomic numbers must be equal. So upon neutron bombardment, an unstable nucleus is produced, which is symbolized with a little star next to it. So to figure out how that formed, we know that we had some isotope plus a neutron. To identify what the nucleus is, we use the atomic numbers, the bottom number. So what plus 0 makes 23, or 23? 23 has the same symbol, V. The mass number is the different number. What plus 1 makes 52? So we're starting with vanadium 51. This quickly decays through beta decay, so we form this particle. Plus, to figure out the other product, we know that the numbers on the bottom have to equal 23, or X equals 24, which using the periodic table we see is chromium. And the mass number has to equal 52, so it's just 52. We can write this in shorthand notation, which is the reactant nucleide, and then in parentheses, the particle going in, followed by the particle going out, and then the product nuclide. So for this one, the shorthand notation is vanadium 51 with a neutron going in, a beta particle coming out, forming chromium 52. For another example, we see the formation of the unstable nuclide, copper 64. This forms from the neutron bombardment of some element. And it produces, in this case, a positron, and then another element. So to identify the initial element, we know that the mass number has to be 20, the atomic number has to be 29, and the atomic number has to be 63, because 63 plus 1 is 64. The new element formed has to have an atomic number of 28, because 28 plus 1 is 29. This is nickel, and the mass number is 64, because 64 plus 0 is 64. In shorthand notation, it's the starting reactant, followed by the neutron in, and the beta particle out, followed by the final product. And we could, in fact, write this using our symbols. For a neutron is an N, and for a positron is B+. Finally, we see the formation of the unstable nucleus, Al23, which forms from the bombardment of a neutron and produces a new particle through beta decay. So the initial particle is still aluminum with a mass number of 22. And the final product has a mass number of 14, which is Si, and a mass number of 23. Atomic number of 14, mass number of 23. In shorthand notation, it's 22Al N beta Si 23.